Hey chemistry family, we are going to be doing some problems that are two-step mole problems, meaning that instead of just going from one island to another, you might be going to more than one. So if we start with question number 3 off of our third worksheet, which is two-step mole problems, you have here a starting idea of 946 grams of SO2. And we eventually want to know how many molecules that is of SO2. So that's MC. SO2. Okay? So let's think about how we would get there. First of all, if we are starting in grams of SO2, that means we'd be starting in mass island. But if we're looking for molecules, molecules is part of particles. So that means we'd end in particle island. So that means we would start in mass, we would end in particle islands, but before we could get to particle island, we would have to stop at mole island. So that means that this is going to be a two-step problem to go from mass to mole island and then mole to particle island. All right, so let's do that and see what that would look like. If you can do one-step problems with the mole map, you can definitely do these ones. So here we go. We're going to do 946 grams of sulfur dioxide. From there, we're going to go from mass island to mole island, which means we're going to use this right here, our conversion factor. So if I have 1 mole of SO2, on the bottom it says I'm going to put molar mass. Now my molar mass, remember, is just the mass from the periodic table. So that means for this molar mass, I'm going to add up 1 sulfur plus 1 oxygen plus 1 oxygen. And when I do add that up, that comes out to about 64.07 grams. Remember, that's my molar mass I got from the periodic table. All right, so let's put that down at the bottom, just like our conversion factor says to do. So that's 64.07 grams of SO2. Now, normally, in our last problems, that would have been it, but we're not at our answer yet. We're stuck in moles, and we need to get to particle island. So to do that, we take this bottom bridge, and we're going to use this conversion factor. So I'm going to use Avogadro's number, 6.02 times 10 to the 23rd, and that is going to be molecules of SO2. And then on the bottom it says put 1 mole of SO2. Now the reason that we like this mole map is it automatically does the work for us as far as canceling out units. We started with grams, and grams are now gone because they canceled out kitty corner to each other. We then were in moles, and moles of SO2 canceled out, and now we're left in molecules, which is exactly what we wanted. So, in order to do this math problem, remember we always multiply everything that's on top, and you always divide by the numbers that are on the bottom. All right? So if we can write that out really quick, it would be 946 times 1 on top, divided by 64.07 on the bottom, times 6.02 times 10 to the 23rd on top, divided by 1, and hit the equals. When you put that in your calculator and get everything out, you end up getting about 8.89 times 10 to the 24th molecules of SO2. So still tons of molecules. Now, do yourself a favor, throw that in your calculator and make sure you get that correct answer. If your exponent is off, that probably means you're not putting in your calculator right, and I would recommend you looking up in our class notes the scientific notation in a scientific calculator, or Google it and look up a video so that you can find how to put that in properly. But that is our first two-step problem that I'm showing you through video, and hopefully it's not that big of a stretch and that big of a difference from our very first one-step problems. All right, let's look at question number 4 from our worksheet. We're starting in grams, right? So if we have grams, we know that's the same as mass island, okay? And if we're looking for liters, we know that's going to be at volume island. So in order to go from mass island to volume island, we are going to have to stop at mole island before we get to volume island. All right, so we can do that. But let's make a note of that. Mass to moles and then moles to volumes will be our conversion. All right? So I always have to start with the values I've been given, and in this case, I have 87.24 grams of carbon monoxide. Now from there, I want to go from my mass to moles, which is going to be 1 mole of over more mass. I'm still in carbon monoxide, so I'm going to put 1 mole of CO. And molar mass on the bottom is the mass from the periodic table. And in this case, it's just going to be 1 carbon plus 1 oxygen. When you do that, that ends up being about 28.01 grams of carbon monoxide. Now that's not done. We're in moles right now, but we need to get to volume, which means we need to do one more conversion factor. And that is 22.4 liters, as you can see from this conversion factor right here, divided by 1 mole. And don't forget to carry over your carbon monoxide. That'll be good practice, because when we start canceling out things, we'll eventually start transitioning and converting from one compound to another. So labeling will be good practice. Grams of carbon monoxide are gone now. Moles of carbon monoxide cancel out, and we're left with liters of carbon monoxide, which is exactly what we were looking for. So if you put that in your calculator, remember you're always going to multiply the top numbers and then divide by the bottom numbers as well. So anything on top multiply, anything on the bottom divide. So this will be 87.24 times 1 divided by 28.01 times 22.4 divided by 1. And when you throw that in your calculator, the answer you end up getting is about 69.78 liters of carbon monoxide. All right? Double check your work, see if you got the same. You can always rewind, pause the video, etc. But now you've done a 2-step mole problem, and that was actually question number 4. All right, Chem fam, this is number 5. Let's try this one out for our last example of walking through. I have 250 molecules of C6H12. That means I'm at particle island to start with. Perfect. It then says that I want to convert to liters, which is volume island. I now know then that if I'm at particle island and I need to get the volume island, I do need to stop at mole island first. And hopefully you're seeing that trend. If it's a 2-step problem, you are always going to stop at mole island first. So let's put our numbers down. I have 250 molecules of C6H12, okay? I then, starting at particles, am going to go to moles, which means I'm going to use this conversion factor, which is 1 mole of C6H12, over Avogadro's number, which is 6.02 times 10 to the 23rd. And this is molecules, so I'll put MC for molecules of C6H12. Now I like to label everything because eventually when things get a little bit more complex, it'll be easy to see what goes with what. So hang in there, and I recommend you keep doing that. Now that we are in mole island, we now need to get the volume island. And to do that, we're just going to use our conversion factor of 22.4 on top for the top part, and 1 mole on the bottom for the bottom part. I'm going to carry over my compound, C6H12, and I'm going to double check that my units cancel. Molecules and molecules of C6H12 go away. Moles and moles of C6H12 go away, and I'm left with the units of liters, which is exactly what I was looking for. So perfect. I'm going to multiply everything on top, divide by everything on the bottom, and the answer you should end up getting after you put it in your calculator is about 9.3 times 10 to the negative 21st liters of C6H12. All right, again, check your answers. Make sure that that exponent is correct. If it's not, you're probably putting in scientific notation improperly into your calculator. That's something definitely valuable to check. But regardless, you've had 3 examples now from your worksheet that hopefully can help you get more comfortable and confident as well with these problems. Nice job today, Chem Fam. Take care.